Hello everyone. So here with another video on how to use CalcPlot3D. This time we're going to talk about parametrized surfaces. And so this would be relevant if you, one, just want to know if you have correctly parametrized a surface or want to visualize a parametrized surface. And also if you're doing like a surface area problem, want to visualize like what you're doing there, especially when we take like just a piece of a surface, right? If you want to see what piece is that. So you're going to add to graph. You're going to go down to parametric surface. And it's naturally going to give you something that is in terms of two parameters. So similar to when we did space curves, but add an extra parameter, and they are going to be u and v. So I'm just going to click on the default one. And we'll see that this is a sphere, and it has radius 2. If you know your spherical coordinates well, v is phi, and u is theta, right? So notice cosine theta and sine theta. The 2 is your r, or I guess your rho in this case because of spherical coordinates. So rho is 2, that's showing up in all. And this is sine of theta, cosine of theta, that's giving you the going around 0 to 2 pi around the whole thing in the xy plane. And then your phi, this is just kind of part of your translating x and y if you know those formulas or look back. And here is where it makes the most sense because we're looking at 2 cosine of phi from 0 to pi. So from 0, we're up at 2 to pi. When cosine is -1, we go down here to -2 for our z, right? And at pi over 2, z would be 0. We'd be in the xy plane. So this last part is where the phi angle is really coming in and giving us our height. So this is one way you can do it. Something that you might be interested in is figuring out like how different u and v combos allow you to figure out where you are. So you can just click on a point, or if you want to know like, okay, if u is 2 and v is 1, like where am I? I am over here, right? And so you can actually see your rectangular domain below, right? So u is allowed to go from 0 to 2 pi, so a little past 6. V is allowed to go from 0 to pi, a little bit over 3. And if you specifically click on 2, 1, then you're at this point, right? And so this might be helpful a little bit. Want to show you another couple things you can do. So I'm going to actually remove this for a second. I'm going to add another parametric surface. I'll click this one off. This one I think is just really, really cool. So the second kind of default that it has is the Mobius strip. So this is really neat because it only has one surface, or like one side to it. So if you start here and travel along this side, you go around, you're on top, you're now behind back here. And so you're kind of underneath here. And then when you're under, you're going to pop right back out here, right back where you started. So you never went to the quote unquote other side. There is no other side here. And so this is just a really cool surface, and you can kind of, look around. There's no just straight up like top and bottom to this because of this interesting twist. If you want to deal with like a plane, for instance, right? So if I had the plane, I don't know, z equals 3x minus 5y, then something you could do that's really easy would be x is u, y is v, and then just plug in for z, right? So z is then 3u minus 5v. So if we do that, u, v, 3u minus 5v, then we're going to get a bit of a plane. And if we said like u is between 0 and 2 and v is between -1 and 3, I don't want this I here, then you can see the piece of the plane that you get, and I can zoom out and show you that it truly is finite, right? So it cuts off here. It's not something that goes on forever because I am restricting my u and v domain. So this is especially relevant for surface area problems where you're only looking at pieces of your surface. We could do the classic paraboloid, right? Z equals x squared plus y squared. So I'll still use u and v, and then this would just be u squared plus v squared, my x and my y, both squared. but we're only seeing the piece of the paraboloid where x is between 0 and 2 and y is between -1 and 3, right? So my x 0 to 2, my y -1 to 3 here. And here I definitely need more steps for my y to make this less, I don't know, rectangular. And now it kind of smooths out, right? But if you did like -5 to 5 and -5 to 5, after it loads, now you're going to see basically your whole bowl shape, right? So just wanted to show you how you can enter some parametrized surfaces, how you can restrict the domain specifically for those surface area problems, and just kind of play around and see what is possible here. So hopefully that helps, and you can visualize these problems a little bit better.